A lot of the messaging is that HPC is just becoming infused throughout the technology, throughout our economy. It's just moving into so many areas. And that's a great message and very valid.
What is the impact of this kind of a global fragmentation on the open collaboration process that science has relied on over the past 200-300 years?
Right now, there's nothing, I think you and I agree that there's no other more important development in the news than this intensifying trade war around advanced chips. It's really directed at HPC and supercomputing. What are the key characteristics of a scaled up environment and the kinds of applications and workloads that's particularly well suited for?
A great definition of scaling is when you can increase capacity and capability faster than you increase complexity.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey, Shaheen, great to be with you again.
Great to be here. SC22 is approaching.
Well, certainly SC is a big high point of the year. The U.S. biggest conference of the year, certainly. It's funny, we were looking back at their little pithy slogans for each year. And what we came up with, HPC matters, HPC now. One conference was more than HPC. Then there was science and beyond. And this year it's accelerates, which might be an acknowledgement of what? The
accelerators?
Is it burgeoning of architectures that are being adopted? I don't know what it might be.
I got the full list here, so I'm going to just go down the list. SC14 was HPC Matters. Mm-hmm. I didn't especially like that one. I thought that should go without saying.
Do we need to be told that, right?
Yeah, exactly. SC15 was HPC Transforms. That was good.
That's good.
SC16 returned to HPC Matters. Clearly, they liked that and they thought it still matters. SC17 was HPC Connects. SC18 was HPC Inspires. Really good. I like that one. SC19 was HPC is Now. Now is a very powerful word too. I like that one. SC20 was HPC is Everywhere We Are More Than HPC. So it was a bit of a mouthful, but good concept there. SC21 was Science and Beyond. And SC22 is HPC Accelerates. So that's definitely a nod to AI and accelerators.
Yeah, exactly. And a lot of the messaging is that HPC is just becoming infused throughout the technology, throughout our economy. It's just moving into so many areas. And that's a great message and very valid.
It truly is. And of course, some people say, no, it's really AI that is. And HPC continues to be technical simulation, number crunching. But you have to remember that the discipline and the algorithms and the skill set of AI is substantially HPC.
Well, and without HPC class compute, AI would be nowhere. What's enabled AI to come out of its last winter is multi-architectures, CPU, GPU, but also just the incredible power of these systems.
Right on. And as we discussed with John Gustafson and others on this show, if you say AI no longer needs 64-bit computing and let me go down to fewer and fewer bits, those are also being adopted by HPC. So the blending of HPC and AI will continue with mutual impact. But the algorithms and the skill set and the infrastructure and all of that is very, very shared. So it's definitely impacting society in big ways. And also, as you mentioned in one of our episodes, HPC is probably one of the unsung heroes of COVID and how we got to a vaccine so fast.
Exactly. And by that, I mean to the general public. It's amazing how many otherwise well-informed people I know. And, we're talking what I do and cover. Almost none of them have ever heard of NVIDIA. It's just the funniest thing. The importance of the AMD, NVIDIA, Intel, Samsung. I mean, what these companies are doing, TSMC. And most people have no clue what's happening. I think it's phenomenal,
That's a great pivot to our next topic, though, isn't it?
Yeah,
Chip wars.
the chip wars, and it's really exciting. We have an upcoming guest who has written I think, a very important book called Chip War. Chris Miller of Tufts, the Fletcher School. He's a diplomatic historian, and he's really taken on this topic. But right now, there's nothing. I think you and I agree that there's no other more important development in the news than this intensifying trade war around advanced chips. It's really directed at HPC and supercomputing, where that the U.S. and the Biden administration wants to cut off China's access to these advanced technologies.
Yeah, absolutely. I think there's, as we've said, there is growing recognition that the engine of economic growth in the coming years and decades is highly dependent on semiconductor technology. As I like to say, the engine of agricultural revolution was the plow, let's say, and
Mm-hmm.
harnessing animals to do a more efficient job of that. The engine of economic growth for industrial revolution was the actual engine, the word we use to say
Mm-hmm.
a lot of other things, starting with steam engine, but then over time to electromechanical and now electric engines. And the engine for information revolution is semiconductors and chips. And that is exactly why there is such a big global attention put on this.
Yeah, it's become geopolitically at the center. But it's funny that one of the articles around this whole issue is there's been the need to define what is a supercomputer, and the administration has put it at 100 petaflops. I looked up the last top 500 list, and that would put it 100 petaflops is right between numbers 6 and 7 on the top 500 list of the most powerful supercomputers. So everything below that is okay, but not above.
Well, of course, the trade conflicts are permeating well beyond that. With the
Yeah.
supply chain restrictions, there was news that TSMC has announced that they will not be manufacturing for the Chinese AI chip vendor Baren that presented at the Hot Chips conference a few months ago.
Yeah.
And that's a visible escalation of that conflict. The impact on Huawei has been non trivial and continues to expand.
Hmm.
In the meantime, I think the Europeans are trying to figure out what to do. And part of what they're doing is to invest locally in Europe in all manner of technologies. Everybody's seen the movie before, from starting with the jet engine and how all of that got consolidated first in the US and then the Europeans let go, only to come back with Airbus and other defense contractor types. And now with AI and quantum computing and new technologies, nobody wants to let go. Everybody wants to invest, and that's pretty significant.
Yeah, there's this drive toward indigenous technology not being dependent on other regions, other countries. It's impacting the whole semiconductor industry. It's a reason, if not the reason. We've certainly seen the stocks of the major semiconductor companies slump badly, and they're lowering their estimates. We also, the general expectation of a global recession over the next 2 years as well. But certainly, these restrictions on China, a huge market for advanced technology, is damaging these companies as well.
Yeah, and you could argue that fragmentation is one of the causes of the global recession.
Mm,
And the question that I keep raising with many of our all prominent guests who are deep thinkers is, what is the impact of this kind of a global fragmentation on the open collaboration process that science has relied on over the past 200-300 years?
yeah,
Is this
yeah.
going to impact the advancement of science because people can't collaborate as much as they did before? And so far, the answer seems to be not yet. It hasn't really impacted, and that area continues. So I'm hoping that it does, but I can't help but think that at some point it's going to get impacted, because friction is friction.
Yeah, yeah. It's such a great point, Shaheen. I mean, at SC and ISC, you see these beautiful young people in these student cluster competitions. Many of them are from China and Asia. And maybe the world should be run by scientists and not politicians. I mean, then we could all just move toward advancing and working together. When you think about the slow pace, really, these brilliant people working on scientific problems and how long it takes to make significant advancements, you're right. If things are fragmented, the scientific progress will do nothing but slow down. But another story came up this week that I found very interesting. I'd love to hear your insights into it. AWS and a 9-year-old startup called Tidal Scale
Oh, right.
have been working on the problem of scaling up on the AWS cloud. Maybe we could talk about the differences between scaling out and scaling up. What are the key characteristics of a scaled up environment and the kinds of applications and workloads that that's particularly well suited for? But I don't know if you saw that story, but Tidal Scale,
I did,
yes.
yeah.
Yeah, they're in El Gato, California. El Gatos, which I guess means cats, right?
Is it Los Gatos?
Los Gatos. Yeah, that's it. Sorry.
Does mean cats, and it's in the Bay Area. It's
Okay.
right between, let's say, Palo Alto and on the west side of San Jose.
There we go.
Beautiful place.
Mm-hmm.
And I am familiar with Tidal Scale, and I think their origins were at SAP Labs. That's where some of their founders came from. Extremely good team.
Yep. And they're getting toward $40 million in raising venture capital, again, over a 9-year period.
So they've been definitely one of the new entrants into the shared memory scale up aspect. So let's talk a little bit. I have a lot of opinions on this, so this is great. I appreciate that.
Okay.
So
Have
yeah, exactly. So scale up and scale out also are other ways of saying shared memory and distributed memory.
Mhm.
And when you're scaling, of course, you're trying to replicate resources. A great definition of scaling is when you can increase capacity and capability faster than you increase complexity,
Okay.
right? That's one way to think about it.
Of the infrastructure, of the
Of the
computing.
infrastructure,
I
right?
got it. Okay.
So you increase capacity and capability by replicating resources. So those resources start at functional units, then you go to cores, then chips, then boards, then computers, then that leads to clusters, and then rows and racks and data centers. So you can scale at every level, right? And the big difference between shared memory, distributed memory, scale up and scale out is really the replication of the operating system. You can think of it that way. If you have a single copy of the OS that has the command of a whole lot of resources, CPUs, memory, this, that, and the other, that's essentially shared memory. You have one copy of the OS that commands it all,
Mhm.
which means multiple processors are sharing that same memory under one copy of the OS. And then shared memory is like you're all sitting in a classroom and there's a whiteboard and somebody writes on it. Everybody immediately sees it. Distributed memory is when you write notes to each other and throw it across the classroom like you did in high school.
Uh-huh.
And so one of them is more scalable and the other one is easier, but you can only fit so many people in the classroom. You can make the analogy that a shared memory system is about how these different resources communicate with each other. If they don't need to communicate with each other, well, then they can all be separate, and that's scale out.
They can go off and do their assigned tasks.
Exactly. So scale out is when multiple computers are connected together through some kind of a network, and that network can be pretty loosely connected if you don't need to communicate a whole lot. As you become more and more supercomputing class and you got more CPUs and more memory and more IO that need to communicate with each other, that interconnect becomes heftier and you go from Ethernet to InfiniBand to some of the specialized ones that you see in the top 10. And one way to think about that is that the viscosity of the glue that you use to connect these things increases as you go from Ethernet. You could argue wireless connectivity can also work. With 5G, you could think about that. I've been waiting for a 5G quote interconnect to show up, and that seems intriguing to me.
Mhm.
But then when you have shared memory, then you have like really concrete that's connecting them together. It's not a glue anymore. it's,
Yeah.
it's so that's another angle that you can think of. Also, as you go up from Ethernet to InfiniBand to specialized interconnects that you need for shared memory, your attention shifts from bandwidth to latency to coherency. So HPC really led scale out. HPC was really the first market segment to say that, I can use multiple lower price, more economical resources to do a big thing. And at some point you say, I can just get a cluster of workstations and get to where I need to get to. I need to rewrite the code to make sure that the communication requirement is not excessive, but I can get there. And that was initially with just clusters and then Beowulfs and then massively parallel systems that were in the same zone, maybe even before the clusters.
Right.
The commercial world, and this is really why most of the shared memory activity scale up is really coming out of the commercial world, transaction processing world. That's harder to do in a distributed memory way.
Mm-hmm.
Those systems generally like to have a lot of processes bang on the same data in memory and on disk. So that's more helpful for them.
Yeah, well, what Tidal Scale is doing, your emphasis on shared memory, I think is right on because, the article I wrote yesterday based on a blog from AWS about all this, there's a key sentence here. Tidal Scale vertically scales up horizontally scaled AWS Metal instances by virtualizing processors, I/O, and memory to create scalable, coherent, shared memory.
Right on.
So that's really the key. And I wonder what the future implications of this are, though, as this, assuming this capability works as advertised and as it becomes increasingly capable. If this could really be further impetus, as you say, especially on the commercial side of adoption of cloud for HPC, but also how this might impact, maybe be a next stage almost of composable computing.
Absolutely. I think it's a great way to do composability. If you can go grab some resources across the data center that you need. Also, when you do shared memory, you consolidate. And when you consolidate capacity, you also consolidate excess capacity. So you now have a larger piece of capacity that is available for usage by different applications. It can have positive implications on availability and recoverability. So it generally gives you better efficiency if the overhead of doing so and the cost of doing so is not prohibitive. So the nirvana is what they're saying, is that you're leveraging volume technology to create value, so to say.
Yeah. I remember at a great presentation England Go of HPE gave 2017 ISC, and it was all around the theme of memory centric computing. But he said there will be a time when there will be a decade of corporate data in live memory and shared memory. I wonder if this is a step toward that, possibly.
Definitely can be. And it's promising and it's very good. When shared memory hit the wall, so to say, people started looking at non-uniform memory access, NUMA, as a way of doing distributed memory that is nevertheless under the purview of one single address space, one single copy of the OS. Sequent computers were the first to really pursue that in a commercial way, and they had really good collaboration with Oracle. SGI did with Origin and then with their ultraviolet, and they're in fifth or sixth generation
Mhm.
of that
Yeah.
interconnect. Sun Micro, we had a project that we never productized called Wildfire that had so-called COMA, another acronym for
Mhm.
NUMA. There were a raft of other vendors that have come and touched on shared memory, and many of them got acquired. Scale MP came up and did it through networking, and you could do it with or without the network dongle, if I remember correctly. It sounds like, according to Next Platform, they got quietly acquired into SAP. And then Tidal Scale was the last
Yeah.
one, doing it at the hypervisor level,
Mhm.
not at the hardware address level, which sort of requires you to build new class of hardware like SGI and now HPE do, but also not at the networking level like Scale MP was doing. So somewhere in the middle, presumably to get the benefit of the efficiency without the cost of extra
Yeah.
hardware. So good activity, solid team, and something to watch.
Definitely something to watch. Very good. All right, Shaheen. Well, as we get closer to SC, looking forward to seeing you in Dallas in a couple of weeks and our upcoming guests on our podcast.
Absolutely. And if any of our listeners are in Dallas on that Sunday, let me know. We have a Dead Architecture Society meeting that we brought up when Jack Dongara was a guest as well. I don't know whether that made it to the final cut or not, but it's a reunion, and it's a nice time to reminisce and think about all the architectures that have come and gone. So,
Yes. All right, Shaheen. We'll see you soon. Thank you.
all right, take care. Thanks a lot.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of Orion X in association with Inside HPC. Thank you for listening.